built environment, and it's a pleasure to welcome you to the 6th installation of Impact at BE, our regular talk series that looks at how our research is collaborating with industry, society and communities to have a positive impact on the world we inhabit. I'd like to acknowledge that today we're on Bejugal land. I'd like to pay my respects to elders, both past and present, and extend that respect to any First Nations peoples who are joining us. So today's lecture is going to talk about how the New South Wales Department of Planning and Environment is working in partnership with the UNSW High Performance Architecture team, many of whom are sat just in front of me, to deliver and develop the first phase of a smart and cool spaces project. The project's goal is to establish a national heat vulnerability observatory, and it's developing a pilot in Maitland and Dubbo with a view to scaling up the project across Australia's largest cities. Today we'll be hearing from 4 speakers. We'll be hearing from Associate Professor Landing, Professor Deo Prasad, Dr. William Kraft, all of UNSW, and Ben Maddox, Principal Sustainability Officer at Maitland City Council. So without further ado, I'll pass over to today's speakers.
Okay, thank you. So this is one of our big impact projects. There's a lot's been happening in the area of urban microclimates over time. And that includes experts at this university, and we acknowledge other works going on in Australia. One of the things we found was the lack of consistency in methodology and approach and the way analytics are handled and how conclusions are drawn about mitigation and other strategies from the data that's collected. So Lam, who is the project lead here, and the team, we've been talking about how we can centralize a lot of the activities. There are many elements to this, we thought. With the significant meteorological events, urban heat extremes and so forth, and there's a lot of population and urban characteristics work that you can relate all the urban microclimate issues with. So sorry about that. We're trying to make it a bit clearer for you, full screen. And there are obviously factors like outdoor environments. What else is influencing the urban microclimates? Building typologies and things. What are the health and other impacts that we can draw from it? We know a lot of data exists in the medical area about heat-related stress and morbidity and so forth. Also it links back to the carbon issues, electricity demand, peak times and so forth in summer in particular. There's a whole range of mitigation strategies that are being explored. We try to put some methodology and consistency in thinking around a lot of these things. And we work with the New South Wales government, as Phil mentioned, the Digital Twins program, because data like this can very effectively link with the digital twins to provide appropriate information to developers and all else. Open Air is another program of the department here, which looks at air quality more broadly. So for an urban planner, urban designer, you need lots of data at the same point, if you like, and government data platforms which can serve these. So the project we are looking at is going to look at urban data. We are going to serve it from the government portals in that sense. We deal with all the issues of data quality and secure by design approaches and so forth, and make it available to all levels of government for their design, planning, and other decision making about how do we deal with this matter of increasingly heat-driven urban environments in the future. So we started something called the National Heat Vulnerability Observatory. Observatory by nature is going to be ongoing, continuous. So the state government here funded us to start two test sites, and Phil mentioned Maitland and Dubbo. We are trialing our methodologies at the same time, the sensors and where we place them, both from the point of view of collecting good data, but also from the point of view of all the human factors associated with collecting data using sensors, like security and how we can keep it there without them going away at random. So we are trialing, testing a whole bunch of these so that we can provide information, good information, quality information back to councils and other government agencies who may benefit from good quality of design, and through the digital twins to many others who may use them for other purposes. So this particular initiative started about a year ago, and Len will describe in detail some of the work that's happening and how to build on that in terms of a nationally consistent approach so that all cities can benefit. We are targeting eventually every large and not so large cities around the country, especially the not so large in remote areas where they may not have access to a lot of these things by themselves. So a centralized observatory would be probably the better way to go. So I'll pass it to Len to describe the project itself in some detail. Thank you.
Thank you very much, Dale. I would like to give a very brief introduction to the key components of the project. Okay, so before I start, I would like to introduce the project team. Besides Scientific Professor Dale Prasad, Dr. William Kraft, myself, also we have got Dr. Henry Peterson, Su Han Yang, Tony Jing, and Kenning Shen. I would like to also thank the great support from Professors Matt Morris, Philip Oldfield, Riccardo Paulini, and Bing Jiao. As Dale has described, this is an ongoing project and with collaboration with New South Wales government and two councils. One is Maitland, another is Dubbo region. This project has three main components. The first is about the development of heat vulnerability index and benchmarking methods. Different from other existing heat vulnerability index, this project covers not only population vulnerability related to human health, but also in-depth analysis of built environment sensitivity to urban heat and electricity demand, as well as integration with mitigation strategies. This National Heat Vulnerability Observatory Index aims to help governments to assess all important aspects related to resilience of a city to urban heat and support their decision making. The second component is about urban heat mitigation scenarios analysis through modeling and simulations tailored to specific local contexts. It will inform local governments which mitigation options and to what extent it could reduce heat vulnerability. The third component is data interoperability. The benchmark data sets, mitigation scenarios, and heat vulnerability index can be shared by different government platforms, including New South Wales Digital Twin platform, as Dale has indicated. I will briefly introduce the three key components. First component is about heat vulnerability index. Dr. William Kraft will introduce detailed methodology and innovative aspects of this index. I just would like to highlight this Heat Vulnerability Observatory Index will analyze not only outdoor thermal comfort, but also heat-related morbidity and mortality and electricity demand. And it will also look into government mitigation, how government mitigation and adaptation strategies could reduce the heat vulnerability level. Just an example about the health data we have collected for the 2 pilot cities. The second component is about the overheating mitigation scenarios through modeling and simulations. So these 2 images show the geolocations of Dubbo region and mainland city. So Dubbo has hot summers. Consecutive days over 38 degrees are becoming more common in summer. And heat waves are also a significant and growing issue for mainland city. And Ben will talk about that in a minute. And we have identified 2 case studies in Dubbo region based on council suggestions. It will include also subdivision scenarios for their new development areas. The 2 case study precincts are South Lakes and South Dubbo. That show you these 2 case study locations at Dubbo. So the top one you can see still on the development. So council would like to look at the different subdivision scenarios. So for example, if increasing density to 300 square meter lots, how that will impact on outdoor thermal environment. And then another subdivision scenario is about 1,000 square meter lot. So with different subdivision scenarios, then combined with mitigation options and what maximum cooling potential they could achieve. So these are what we could help local governments to support their decision making. So these are examples of different mitigation options, including trees, parks, cool roofs, surfaces, water misting system shading, and then we look into the maximum cooling potential. Similarly, we have identified the 3 case study precincts in mainland city together with mainland city council and with help and support from Ben. So these 3 case study precincts are very interesting. If you look at the top left one, that precinct has a high vulnerable population, and the top right one that include we will run comparative analysis a newly established suburb, and then compare that with an old suburb. So these two suburbs have greenery at a different level. You can see the high density one and a very high level tree and greenery in the old suburb. So then we can look into the thermal heat impact, health impact, and electricity energy use impact. And if newly established suburb has a high impact on thermal comfort or health, what mitigation options can be taken by local government, and to what extent it could mitigate urban heat. And the bottom one is a mixed land use precinct. So this just show you the example of upgrading precincts with high vulnerable populations. So we together work with the government to look into mitigation options to help to reduce heat vulnerability in that area, to help those hopefully could help those vulnerable people during heat waves. Some preliminary results. So you can see the example of cooling potential by cool pavement. The difference in air temperature could reach the 1.5 degree. That means with cool pavement mitigation option, air temperature reduction can achieve around 1.5 degree. The PhD candidates in the UNSW built environment are involved in this project as well. So these photos shows they conduct on-site measurement at Dubbo and Maitland city and Maitland case study precincts. All they are here, yeah, Penning, Shuhan, and Tony. The last component, the third component, is about establishing benchmark data sets and developing data interoperability. So you can see we have different data sources from sensors, for example, GIS, New South Wales Ministry of Health, electricity supplier. So that shows different data sources and then followed by ontology mapping and statistical analysis, then generate National Heat Vulnerability Observatory Index covering urban overheating, health, and electricity. So this part includes protocols of data collection and format, ontology-based methods for presenting benchmark datasets, pilot connection with New South Wales Digital Twin platform, and the data interoperability methods. So I would like to appreciate Dr. Henry Peterson, and he makes significant contributions on this part. And this just shows you National Heat Vulnerability Index, Observatory Index data sets. So you can see it shows the input and output. So input from the raw data sets from different data sources, then process the data sets, then the engine including statistical analysis and a regression model, and we will introduce that in a minute. Then output about the heat vulnerability levels for different cities. This shows National Heat Vulnerability Domain Data Ontology Framework. So the data sets plus all the associations across those data sets are represented using ontology framework. National Heat Vulnerability Data Structure for future implementation. Just quickly, I would like to show you the past project funded by CRC for low carbon living. You can see the visualization of a heat map indicating hotspots in the suburb in the study area, and also real-time monitoring through the sensors, and also 3D visualization of cooling potential. So we will do similar through prototype connection with New South Wales Digital Twin platform. So this is a mock-up user interface providing, so for example, the scenario includes providing real-time monitoring and current heat vulnerability index. So for example, current heat vulnerability conditions, including overheating, health, and electricity. and then integrated with mitigation scenarios, then inform improved heat vulnerability over time. So in short, it's not fixed, it's ongoing monitoring, simulation, and support government decision over time. Okay, just would like to provide a summary about phase one. Phase one aims to develop fundamental elements for the observatory. So that includes city-town specific data sets and monitoring urban heat issues in cities. And also we establish performance measures and key indicators. And we develop analytical modeling and simulation about the what-if scenario analysis to inform cooling potential. And we develop data interoperability, and we demonstrate with 2 pilot cities. And for long-term plan, as Dale has indicated, we aim to scale up to cover more cities in New South Wales and also at the national level. And we will further develop New South Wales or Australian national benchmark data set. And we will further extend to connect with other monitoring data, for example, air quality, UV data, and so on. And with the benchmark data sets, we can further develop AI, machine learning for data-driven decision-making in urban heat mitigation and adaptation. So that's all from me. I would like to thank UNSW project team and the Department of Planning and the Environment team, and the New South Wales Digital Twin team, Dubbo Regional Council team, and the Maitland City Council team. We have been here to talk with you in a minute, and also advisory committee members. Then I would like to pass it on to Dr. William Kraft. He will talk about the methodology and innovative aspect of heat vulnerability index. Thank you.
Great, thanks, Lan. Hi, everyone. As Lan mentioned, a key aspect of this project is the development of the Heat Vulnerability Index. So I'm just going to give you a little bit more detail about what that is and why that's important and the approach we've kind of taken to developing this. So to start with, what makes our index different from others? There are other heat vulnerability indexes out there. We see it as a kind of a combination of 3 different aspects that together make this, a fairly innovative approach. Firstly, and Lan has touched on some of these, is most existing vulnerability indexes focus heavily on the population, the health side of things, which is critically important. We're trying to expand the scope of our index to include a more detailed capture or snapshot of built environment characteristics. So not just looking at, for example, just urban density, but looking at, the street and road networks, the tree canopy coverage, the different roof materials, the sizes of the different lots. So that's kind of the first aspect, which then leads to the second aspect. Again, Lan has touched on this, is the integration of the mitigation and adaptation strategies. So the microclimate so the microscale and the mesoscale modelling that we are doing, which Lan has shown you in the 2 case study precincts, we're planning to integrate those results into the index so that, in theory, you will be able to say, okay, I have a given area. If I'm able to plant more trees or change all of the roofs to a cool roof, what is then the resulting impact through an index value in terms of different performance indicators? And lastly, what makes ours a little different in combination with those 2 things is that we're taking a very data-driven approach here. So we're not just looking at, population characteristics and using that to estimate, assuming that all of those factors are equally weighted to determine the vulnerability of a given area. We're taking the data for a range of different influential factors, and then matching, and as well as a range of different performance indicators. So we're looking at the outcomes of how we can measure vulnerability, and then working backwards to try and understand the relationships between those influential factors and then the resulting outcomes. And that's basically how it works, and that's what this diagram is loosely showing here. So we've defined 3 different areas of heat vulnerability, key performance, key influential factors. So we're looking at a given area. So we're working with the ABS statistical area 1 and 2. So looking at what is the local climate heat profile of that area. So we've got the Bureau of Meteorology heat wave data, and looking at how historically, how many heat waves are in this given area in those case studies, how long do they last for, and how often they're happening. Then we've got the community heat vulnerability profile, which looks at things like population characteristics, mainly from census. So we're looking at here people's age, income, education, whether they've got existing health conditions, things like that. Then we're looking at the built environment side of things. So as I said, tree canopy coverage, different materials, surface materials, building density, that kind of thing. So those are our defined for our scope 1, so our phase 1, so our pilot stage. We're just scoping our index to those 3 aspects. Then what we've done is define different performance indicators, key performance indicators, and Dale and Lan have touched on this, one being electricity demand. So looking at, we've got the electricity consumption data for each of these areas, and we're able to then match that with, during a heat wave event, how does that impact electricity consumption? How is it related to different aspects of the community in terms of their socio-demographics and things like that, as well as the different built form characteristics of that area. We're also integrating heat-related mortality and morbidity. So we've got data from New South Wales Health to do a similar kind of thing. So we've got these 2 levels here, and then we're running a regression analysis to really try and understand the relationship between these factors, and also to what extent are certain factors influencing these performance indicators, which are how we're measuring this vulnerability index. So that's kind of how it's working in a nutshell. And the reason why we're doing this is, firstly, we all know heat is going to be a major problem in our cities going forward. And what the index will eventually be able to give councils, state governments, federal governments, even developers, planners, a relatively simple and easy to understand spatial distribution of heat vulnerability in certain areas. So we'll be able to quickly and easily identify what areas are the most vulnerable. So say if a developer comes along and wants to build a new precinct, which is kind of what's happening in some of our case study areas at the moment. They're still under development. What is the existing heat vulnerability profile, if you like, of that specific area in relation to heat mortality, morbidity, electricity demand, or its outdoor thermal environment. That will then hopefully inform government policy or design and development decisions. And on top of that, being a kind of a regression analysis, it has an element of being able to predict as well. So the idea here long term is that we will be able to take a specific area and hypothetically run different scenarios. So say we have this area now with current local heat profile conditions. what if that was to change in the future? How would that then affect the different heat vulnerability outcomes? So it is going to be a dynamic and ongoing thing that will evolve and expand in the future. So as I said, this is just phase one, and you can see here in red, we are planning to scale up to more cities and more areas, because at the moment we're only focusing on those 5 case study areas that Lan has mentioned. So the more data, more diverse areas that we're able to feed into this, the more accurate and the more enhanced this index will get. And we're able to then add in different performance indicators that, as Lan mentioned, might involve things like air quality or UV, things like that. So yes, that's kind of it from me. I think over to Ben now.
Thanks, Will, very much. Yeah, we pass on to Ben from Maitland City Council. Ben?
Hi all, nice.
Yeah, hi.
Excellent.
Nice to meet you all. Yeah, just want to say it's a great opportunity for Maitland to be part of this project. We've recently had our environmental sustainability strategy adopted, and within that, we have a section on resilience and living sustainably for our communities, and urban heat is a particular challenge for us. So we're just out moving further west from the coast and starting to get that moving away from the coastal influence. And some of our climate data showing that we're getting an average of 7 days per year over 37 degrees. Within our urban areas, we're finding that the urban built up areas can be up to 3.7 degrees higher temperature than the surrounding rural areas. And in 2019, we went through a process of doing some analysis on where our urban heat vulnerabilities are, and we've taken some data from Landsat imagery that shows in the 8th of December in 2019, quite early in the morning, we're finding some pretty significant temperature differences between the eastern suburbs and the western suburbs. And we're finding that there's a varying level of canopy cover across the city. So in that analysis, we're finding that as we move to the west and develop those areas, we need to consider what that means for our community and how urban form will impact upon the livability of those areas. Obviously, we need to have concerns about not only the urban heat impact, but things like energy consumption and the like are also a risk factor for people that are living in those areas of vulnerability. And we need to be mindful that that has a cost of living impact as well as potentially a health impact. So, Lan, do you want to move to the next slide if the guys are seeing that? Or they can't see, they're seeing me talk. So Lan put up earlier the areas of study that we're doing, and as you can see, there's some varying levels of different urban form. Across the city, we see our canopy cover in suburbs vary quite starkly. So some areas are quite high in canopy cover, up to 50%, and others are quite low, down as low as 1.2% canopy cover across the city. So what projects like this allow us to do is test what things like changing the urban form, canopy cover, cooler roofs, cooler infrastructure can actually do to support a more livable urban form, especially as we move towards the west. And these will help us immeasurably when we're doing things like reviewing our development control plans, how we're helping provide master plans for new areas. So what we're hoping to be able to do as part of this project is to use the results to guide what interaction and negotiations we can have with the development industry to find solutions that maximize those treatments that we can see. And we're already seeing from some of the preliminary results that the team has been able to produce that there are significant opportunities by making some changes to urban form to improve the community's resilience to the impacts of urban heat, which we know under varying scenarios are likely to get more persistent and prevalent. In regard to moving forward, as I said, looking forward to getting our real-time sensors out in the field and seeing how that data can be integrated and build a living lab on how we can maybe apply some treatments over time and see the actual impact of those aspects in already existing areas. But again, more importantly for us, we've got a high level of population growth occurring, so getting that urban form right and providing more resilient opportunities for our community is a key area that we think we have a responsibility to pursue. So, Lan, did you have any questions you want to put to me about how we would further use this information?
Sure, thank you so much, Ben. Yeah, perhaps we could start with panel discussion. Ben, what group within Maitland City Council are likely to use or benefit from the outcomes of this research, and in what way?
So internal stakeholders are definitely our strategic planning team. So the teams that are reviewing and developing our development control plans, our housing strategies, how we guide urban form over time. It also helps support our subdivision engineers to understand the benefits of different design guides in our manuals of engineering standards and the like. But it also helps, we believe, our interaction with developers. We have regular developer forums where we talk through the opportunity to make sure that we're providing a more livable environment for our community. So having this evidence base helps us have those conversations to say we're putting forward these options from a place of research and evidence and working together to achieve an outcome.
Thank you so much, Ben. Now, Dale, what do you think about the impact of this project on the community? And will it inform future smart and resilient cities?
Okay, thanks. Yeah, so huge impact. We are trying to collect data on health aspects and relating it to different levels of heat stress due to climate. So we understand Eastern Sydney, Western Sydney differences very well now in terms of how intense it is out west. We find that a lot of the contributions to that came from design planning choices and so forth. So how can we try and put the evidence in front of the decision makers so that they mitigate and also avoid there's a whole new city being built out there so that the same things don't get repeated over there. There is a very direct link. Data shows the link with mortality and morbidity and so forth. It is amazing level of correlation, especially with the elderly and sick and so forth. So I think a project like this, not only in any city, but can cross compare between different types of zones and areas and climates and cities around Australia using standardized common methodologies so that you can compare because if you don't want there to be significant differences in answers simply because of methodological approaches. So we want to, by standardizing that, we like to get comparable answers to lots of the questions. Hence, the idea of a national observatory that would expand hopefully to all cities in Australia down the line. So I think in answer to your question, yes, huge difference for community well-being and through design and planning of resilient cities, we can see the advantages for the community.
Thank you very much, Dale. Will, what do you see as the future progression of the National Heat Vulnerability Index? What is needed to make this happen?
Thanks for that. So I guess I touched on this a little bit before, and we've all kind of mentioned it as well. As you know, this is a pilot project. The most obvious answer to that is it needs to scale up to a lot more cities and a lot more diverse cities around Australia. To be able to do that, I think we're obviously going to need a lot more data collection, huge data linkages. So, for example, even just getting a small amount of health data into this project took a huge. It's not an easy thing to do, and it gets quite complex. And you need medical expertise to help determine, what specific, medical codes are heat related, because there are direct causes in terms of heat related deaths and morbidity, but there's also the indirect as well. So it will take a lot more data, a lot more collaboration, and also expanding the scope. This is just a proof of concept, so we're starting relatively small in scope to kind of prove that it works, and then expand to include other areas, for example, like air quality and so on.
Thanks, Will, very much. Now we open for questions. Any questions to Dale, Will, Ben, or myself?
Thank you very much for an interesting presentation. You indicated that there were some pilot areas within the cities, the two cities that you're looking at the moment. The first step, I guess, to scale up would be to scale up over the entire part of each one of those cities. Could you give us any indication about how many sensors you would need to cover an area such as Dubbo or Maitland?
So it really depends on a few factors. First is budget and the different types of sensors. For example, the mainland city, they have 5 NOD1 sensors, which is real-time can monitor real-time data, and Hobart sensors 10 and plus. So depends on size of precinct to monitor and the urban typology of that location. If like all the consistent residential area or mixed land, we want to monitor the different locations and to look at the different urban typology or urban characteristics impact on health, thermal, and electricity. So in short, for the 6 case study precincts, we are locating 10 plus mobile sensors and 10 plus NOD1 sensors. So that's about, if you want to use that to inform city-wide, that will be more. That's a very good question, because we had a discussion with another New South Wales government. They look into next step of this project. They said, okay, that's great, but we would like to have some ideas if scaling up to cover more cities, how many 100,000 sensors we need to consider, what budget will be. Yeah, hope answer your question.
Can I just add to that? So when you start putting things in different areas, there are many sensors already in lots of areas monitoring different things, and they are of different types and quality of instrumentation. They have different shelf life and data reliability and all that. One of the things we are trying to do, which LAN has been able to try and work with others, in terms of not using different posts. For example, posts, instead of every time you put your own pole up with sensors, huge problem. So we're trying to see if we can have a system whereby we can have air quality, thermal temperature and other sensors, and any others, like in areas where it is important noise, for example, levels that councils may benefit from down the line. So this is a heat laboratory, observatory, but down the line it may include noise issues, because at a planning situation, if you like, you need lots of data about many different things. And if in the future, with all the artificial and other intelligence and smarts coming along, it would be really good using digital twins, etc., to provide that level of data. So we need to start thinking about it now, rather than lay it out at a level and then 3-4 years when we start getting more funding, then we go and replace them. All those duplication work. We want to start with a plan that is medium to longer term, so that you don't go around changing things very in short future sort of thing.
Yeah, I guess to add to that, there have been conversations to try and co-locate, as Dale was mentioning, with other sensors as well. I can't remember whether it was Dubbo or Maitland or both, talking about the actual street lighting and whether that can be integrated in the actual street light itself. But then there's issues around data quality. If you're taking air temperature measurements, for example, you don't want them to be way up in the sky. You want them to be kind of at the human level, that kind of experience. But yes, it will take, to scale up, it will take significant budget, significant number of sensors, even to just do it across the whole of Maitland or the whole of Dubbo.
Okay, thank you, Will. Do you have any other questions to our speakers? Yes, we have received some questions from our online audience. The first question is, what is the software or platform on which the data is being or has been uploaded?
The sensor data.
Yeah.
Because this project will develop a prototype connection with New South Wales Digital Twin platform. We just had a meeting with them this morning. So they have the module and the function to support real-time monitoring of real-time sensor data.
Okay, thank you, Lan. The second question is, how will the variability of the thermal performance of existing buildings be accommodated, especially in relation to electricity demand?
Yes, that's a good question. In terms of indoor thermal comfort and also like cooling demand, for building at building level, we have one component. So that's because councils are very interested in adaptation strategies as well. So for example, if we're changing from dark roofs to cool roofs, how that could improve the indoor thermal environment, could reduce cooling demand. So we include that energy modeling as well in this project. Yeah, so that really depends on the construction type of buildings in the case study area and urban typologies and so on.
Yeah.
This project has energy modeling component. Thank you.
Okay, thanks, Lan. This last question, what is the expected time frame for the new guidelines and requirements on the new developments? There's so much happening at a high pace. They need a right direction before design went too far. Sadly, best practice advice is not sufficient sometimes to push for increased tree canopy, reduce extent of hard surfaces, and so on. So the question is, what is the expected time frame for the new guidelines and requirements on the new developments?
So we haven't set, we in early stages at the moment in terms of data collection. then we develop and fine-tune all the methodologies that are being talked about before we release any guidelines for consistency. It may be released in stages as we foresee it, because it could deal with just the analytics and basic mitigation type issues. But as you grow further, we might still start looking at building typology issues, and because we are collecting online live data, which is very relevant, we can do a lot with it in terms of decisions at the drawing board, as they say. We can, at the moment, in terms of peak demand, for example, the energy modeling work that is done now through different tools uses older data, for example. We will have latest data at a micro scale to do more specific hotspot information and all of that combined to provide more detailed answers to those questions about peak demand and not only peak demand. In many areas, we find with the new data that we are getting extended periods of heat cooling now compared to before already. So the cooling season is expanding. So it's not only just the peak, but the total energy demand is changing simply because of extended heating periods, cooling periods, and so forth. So coming back to the guideline, a lot of these things can provide input into development of guidelines. And the whole idea is if we can have it tomorrow, but it will take, because we have credibility and quality of the outcomes at the forefront. So it will release it in stages.
Thank you, Dale. That's all the online questions.
On that point, from a local government perspective, yes, we definitely will end up with hopefully performance-based controls in our DCPs that help move us towards better outcomes. But I'm hopeful that as the technology evolves, that we may be in a spot where we can start to model different urban forms and different outcomes at the very early stage of a development process, to try and use that to have a conversation with those that are delivering these developments to say, how can we work together to achieve the best possible outcome. Controls are very important and they'll play a part of it as well, but I think we've got to see that the people that are delivering these communities also have an interest in making them livable. So let's see what we can do to lead into that and support better design.
Thank you so much, Ben. Yeah, I think we can do it.
Yeah,
I think
questions. Yeah, all the questions has been answered.
Okay.
Yeah.
Great. Thank you so much, and thanks Ben, Dale, and Will. Thank you all, and see you next time. Bye.
Perfect timing. Thank you.